We're absolutely swimming in data, right? It's everywhere, from those fun online personality quizzes to major scientific studies. But here's the big question. Can we actually trust it? Well, today, we're going to dig into the two critical tests that any piece of data has to pass before you should even think about believing it.
So what's the real difference between good data and, well, bad data? It all starts with accepting a simple, kind of surprising truth. Every single measurement we take, I don't care how careful we are, has hidden flaws or errors baked right into it.
I want you to think about the last online quiz you took. You know the one. It asks you a bunch of questions and then spits out a result. And boom, it claims to have you all figured out. But is that score really you? Or is there just a bunch of noise messing with the signal? This is the fundamental challenge researchers face every single day. The hard reality is that no measurement is ever perfect. Not a quiz, not the scale in your bathroom, not even some super fancy scientific instrument. There's always some amount of error. And look, the goal isn't to get rid of it completely. That's literally impossible. The real game is to understand that error and then minimize it as much as we can. And it all boils down to this one incredibly simple but really powerful formula. M equals C plus E. Seriously, this little equation is the key to understanding pretty much any measurement you'll ever come across. Let's break this down. M is your final measurement, so your quiz score. That score is always a mix of two things. C, which is the true characteristic being measured, your actual personality, plus E, which is the error. Now that error could be anything, random chance, your mood that day, maybe just some badly written questions. So the entire goal of good research is just to shrink that E down until it's as close to zero as possible. All right, so before we can really start to tackle that error problem, we've got to get a handle on two of the basic tools of the trade for researchers, measurement and scaling. Now, here's a key thing you might not have thought about. We almost never measure people or objects directly. Instead, we measure their characteristics, things like their attitudes or opinions. And we do that by assigning numbers to them based on a very specific set of rules. And scaling? Well, that just takes things one step further. If measurement is about assigning the number, you can think of scaling as creating the ruler that the number goes on. For example, when a survey asks you to rate a brand from 1, meaning extremely favorable, to 10, least favorable, that whole continuum is a scale. Okay, time to introduce our first major test for data quality. It's called reliability. And if you're going to remember just one word for this concept, make it this one: consistency. A reliable measure is simply one you can count on. It means that if you repeat the measurement under the same conditions, you should get the same or at least a very, very similar result every single time. It's all about being stable and predictable.
It's just like stepping on a bathroom scale. If you step on, then step off, and then step back on 3 times in a row and get the exact same number each time, well, congratulations, you've got a reliable scale. The result is consistent.
So, how do we actually check for this consistency? Researchers use a bunch of different methods, but we're going to focus on two of the most common ones you'll hear about: test-retest reliability and internal consistency reliability. The test-retest method is, you guessed it, exactly what it sounds like. You give a group a test, let's say an IQ test. Then you wait a while. Then you give them the exact same test again. Now, since a trait like IQ should be pretty stable, the scores ought to be very similar. If they are, then bingo, your test has high test-retest reliability.
Now, internal consistency is a little different. This isn't about testing over a period of time. It's about looking at all the different questions within a single test to see how well they all hang together. So if you're designing a quiz to measure happiness, you want to make sure all the questions are actually measuring that same idea.
To do this, researchers use a statistical tool with a kind of fancy name: Cronbach's alpha. Now, you don't need to memorize the formula, just understand what it does. It basically calculates one single score that tells us how well all the questions on a test are working together as a team. So what's a good score? Well, the general rule of thumb is that a Cronbach's alpha above 0.70 is considered acceptable. It's just a quick benchmark that tells you if all your test questions are internally consistent. Now for our second critical test, validity. And this is a big one. If reliability was all about getting a consistent result, validity is all about getting the correct result. It is all about accuracy. Validity asks a really crucial question. Is our test actually measuring what we claim it's measuring? Are we hitting the bullseye or are we way off target? Let's go right back to our weighing skill. It can be perfectly reliable, right? Giving you the exact same number every single time. But what if it's always 5 pounds heavy? It's consistent, for sure, but it's not accurate. And that means it is reliable, but it is not valid. And just like reliability, there are a few different ways to check for validity. You have content validity, which asks if the test covers all the relevant parts of a subject. Think of a final exam that only asks about the first week of class. It's got poor content validity. Then there's criterion validity, where you check if your results line up with a different, already established test. And finally, you've got construct validity, which asks the really big question: does this test actually measure the complex abstract concept, like creativity or job satisfaction, that it's supposed to?
Okay, so we've looked at consistency with reliability and we've looked at accuracy with validity. Now let's bring it all together and see how these two concepts work together, because the relationship is really the final word on data quality.
This right here is the absolute key. Reliability asks, can I get the same result again and again? But validity asks, is this result even true? And here's the most important thing to remember. You can have reliability without validity, but you absolutely cannot have validity without first having reliability. Consistency is the foundation that accuracy has to be built on. This quote just nails it. Our faulty scale is the perfect example. It produces consistent results, the same wrong number every single time, but those results don't reflect the true concept, which is your actual weight. So it's reliable, but it is not valid. So the next time you see a headline with some shocking new statistic, or you take another one of those online quizzes, you're now armed with the right questions. Don't just ask what the result is. Ask yourself if the measurement they used was both reliable and valid.